Hello everyone. In the last class you have studied the series expansion, that is a Taylor's and Maclaurin series. Today I am going to give the lecture on indeterminate forms. So indeterminate form, the word itself tells that which cannot be determined. But in mathematics, if an expression f of x at x equals a assumes the forms like these are the forms 0 by 0, infinity by infinity, 0 into infinity, infinity minus infinity, 0 power 0, infinity power 0 at 1 power infinity, which do not tends to a real value is called an indeterminate forms. Then how to find the solution for this indeterminate form means using the L'Hospital's rules you can find the solution of these indeterminate forms. So the next term is L'Hospital rule. For 0 by 0 form. Then how to find the solution of this indeterminate forms means using the L'Hospital rule you can find the solution or you can solve this indeterminate forms. Then what is the L'Hospital rule means? Consider the L'Hospital. L'Hospital's rules, the statement of the L'Hospital rule, if f of x and g of x are two functions such that limit of f of x, limit you can write LIM or LT, both are same, limit of f of x as x tends to a equal to 0 and the limit of g of x as x tends to a equal to 0, then the limit of f of x divided by g of x at x tends to a, you have to differentiate the numerator and denominator separately, that is f dash of x divided by g dash of x as x tends to a, provided this denominator term g dash of x is not equal to 0. So this is the L'Hospital rule. Suppose the next form is also indeterminate form, you have to differentiate the numerator and denominator once again till you get the real value. Suppose the limit of f dash of x as x tends to a equals 0 and the limit of g dash of x as x tends to a equal to 0. Suppose after differentiating these two terms again you get the indeterminate forms means you have to differentiate the numerator and denominator once again, then this tends to the limit of f dash of x divided by g dash of x as x tends to a equals the limit of f double dash of x g double dash of x as x tends to a, provided the g double dash of x, provided the g double dash of x is not equal to 0. This is called the L'Hospital rule. For example, evaluate limit of sin x divided by x as x tends to 0 using L'Hospital's rule. Evaluate the limit of sin x divided by x as x tends to 0 using the L'Hospital rule. And how to evaluate this? First you apply the limit for the sin x divided by x. So consider this term solution. Consider the limit of the sin x divided by x as x tends to 0. First you apply the limit. Since the sin 0 equal to 0, the denominator equal to 0, so it is the 0 by 0 form. Then you can apply the L'Hospital rule, that is differentiate the numerator and denominator separately. The limit of, so differentiate the sin x divided by x, that is numerator and denominator separately. The sin x differentiation cos x, x differentiation is 1. If you apply the limit, the cos 0 is the numerator, 1 is in denominator. Since the cos 0 equal to 1, so we will get the answer as 1. So you continue the differentiation till you get the real value. So the first differentiation you got the real value, that is cos 0 equal to 1. So this gives the limit of sin x divided by x as x tends to 0 equals 1. Similarly, the limit of tan x divided by x is also equal to 1. So I take that as a note. The limit of sin x divided by x as x tends to 0 equals 1. This can also be written as the limit of x divided by sin x. Both are same as x tends to 0. The second term, similarly, the limit of tan x divided by x as x tends to 0 equals 1. This is the limit of x divided by tan x as x tends to 0. Since the differentiation of tan x is secant square x, denominator you will get the 1. Secant square 0 is 1. So we will get the tan x by x as x tends to 0 is also equal to 1. So this is same as the x divided by tan x. So using these notes, you can also write the third note, the limit of sin 2x divided by 2x. These two coefficients should be same. This can also be written as 1. This can also be written as 2x sin 2x as x tends to 0. So using the L'Hospital rule, you can solve the indeterminate forms. If it is a 0 by 0 or infinity divided by infinity. Then 0 into infinity, infinity minus infinity, 0 power 0, infinity power 0 or 1 power infinity. First you convert these into a standard indeterminate forms, that is 0 by 0 and infinity by infinity. Then apply the L'Hospital rule, you will get the real values like this. The second example, evaluate the limit of log x divided by x square minus 3x plus 2 as x tends to 1. First you apply the limit for this problem. So for numerator, the log 1 is 0. Denominator, here 1 minus 3 plus 2, you will get the denominator is also 0. So it is 0 by 0 form. Then apply the L'Hospital rule. That is differentiate the numerator and denominator separately. The log x differentiation 1 by x, x square differentiation is 2x, minus 3x differentiation is 3 into 1. Since the 2 is constant, the differentiation is 0. Then apply the limit, take the limit equal to 1, x equal to 1. So numerator will get the 1, denominator 2 minus 3, you will get the answer as minus 1. Next example, third one, the limit of a power x minus 1 minus x log a divided by x square. First you apply the limit. The first one, if the x tends to 0, the first term a power 0 is 1, minus 1 you keep it as it is. Since the x equal to 0, So this term becomes 0, denominator is 0. So this tends to 0 by 0 form. Then apply L'Hospital rule. This differentiate the numerator and denominator separately. So a power x differentiation is a power x into log a. 1 is constant, the differentiation is 0. Here the log a is constant, the differentiation of x is 1. Denominator, since you have the x square, the differentiation of x square is 2x. So as x tends to 0, a power 0 is 1, log a minus log a, again you will get the numerator is 0, denominator is 0. Again it tends to 0 by 0 form. So goes on differentiating till you get the real value. So since you got the 0 by 0 in the differentiation, so again you apply the L'Hospital rule, again by L'Hospital's rule. Once again you differentiate the numerator and denominator. Here the log a is a constant, keep the log a as it is. A power x differentiation, a power x into log a. Keep this log a as it is since it is constant. In the second term, the log a is constant, the differentiation is 0. Denominator, 2x differentiation, 2 is constant, the x differentiation is 1. Again apply the limit. So a power 0 is 1, you will get the log a. The multiplication of log a, you will get the log a whole square. Denominator 2. This is the answer. The next problem, limit of log of tan x divided by log x as x tends to 0. Here first apply the limit. Since the tan 0 equal to 0, tan 0 is 0, log 0 is infinity. So in numerator you got the infinity, denominator log 0 is again it is infinity. So it is infinity by infinity form. You can apply the L'Hospital rule if it is infinity by L'Hospital rule. The limit of x tends to 0, log of tan x differentiation, it is 1 by tan x. Tan x differentiation secant square x. Denominator log x differentiation 1 by x. Then first you simplify this, next you apply the limit. The limit of x tends to 0. The numerator you have the secant square x, denominator is a tan x. Write 1 by x as x divided by 1, take the term to numerator. Then using this property, that is tan x by x or x by tan x, for the limit x tends to 0, you can write the term as 1. So this term equal to 1. The remaining term, it is the limit of x tends to 0, secant square x. So you know the secant square 0 equal to 1. So the answer equal to 1. Simply don't differentiate the term, the numerator and denominator. First you apply the limit and apply this property if the limit as x tends to 0, whether it is a sin x or tan x. First you apply the property, then you simplify this term, the secant square 0, you will get the answer as well. The next problem, limit of 1 by x minus 1 by e power x minus 1 as x tends to 0. First you apply the limit as x tends to 0, 1 by 0 you will get the infinity minus here 1 by e power 0 is 1, 1 minus 1 is 0. So again the 1 by 0 is infinity. So it is infinity minus infinity form. First you convert this into 0 by 0 or infinity by infinity, then you apply the L'Hospital rule. So if it is infinity minus infinity, you take the LCM, limit x tends to 0, take the LCM, e power x minus 1, cross multiply this, minus x divided by x into e power x minus 1. Apply the limit. So e power 0 is 1, 1 minus 1, this is also 0. So we will get the numerator as 0, denominator. There is a multiplication of x, you will get the 0 in the denominator. So infinity minus infinity is converted into 0 by 0 form. Then you apply the L'Hospital rule. The limit of x tends to 0, differentiation of e power x, you will get the e power x, differentiation of 1 is 0, the x differentiation is 1. Next, apply the product rule. First term, keep the first term as it is, e power x differentiation e power x, 1 differentiation is 0, plus x differentiation is 1. Keep the second term as it is. Next, apply the limit once again. Check whether you will get the finite value or not. The first one, e power 0 differentiation, e power 0 is 1, 1 minus 1 is 0, denominator. Here the multiplication x you have, the first term is 0, second term e power 0 is 1, 1 minus 1 is 0. So again it tends to a 0 by 0 form. Again you apply the L'Hospital rule. The limit of x tends to 0, e power x differentiation e power x, 1 differentiation is 0, denominator, apply the product rule between these two, x e power x plus x differentiation is 1, keep the e power x as it is. Here e power x minus 1, the e power x differentiation is e power x, 1 differentiation is 0. Then apply the limit. For x tends to 0, e power 0, you will get the answer as 1. Denominator, the first term is 0 since it is multiplication of x. Second term, e power 0, you have 1. Next again e power 0, you will get the 1. So the answer is 1 divided by 2. So the next problem, limit of 2x tan x minus pi secant x, limit as x tends to pi by 2. First you apply the limit. So the first limit 2 into pi by 2, tan pi by 2, tan pi by 2 is infinity, you will get the first term is infinity. Since the infinity into any term is infinity, the second one pi into secant pi by 2, the secant pi by 2 is also infinity. So it is infinity minus infinity form. First you convert into standard indeterminate form, it is 0 by 0 or infinity by infinity. Then you apply the L'Hospital rule. So the limit of x tends to pi by 2, keep the 2x as it is, tan x can be written as the sin x divided by cos x, minus, keep the pi as it is, secant x can be written as 1 by cos x. Then you take the LCM, the limit of x tends to pi by 2, 2x sin x minus pi divided by cos x. Now we apply the limit once again. So numerator 2 into pi by 2, sin pi by 2 is 1, minus pi, denominator cos pi by 2 is 0. The numerator also will get the 0 divided by 0. So the infinity minus infinity is converted into the standard indeterminate form 0 by 0. Then you can apply the L'Hospital rule. So by L'Hospital rule, differentiate the numerator and denominator separately. So the first one, since you have the x and sin x, apply the product rule by keeping 2 as it is. The first one, keep the x sin x differentiation cos x plus x differentiation is 1, you will get the sin x. Second term, pi is constant, the differentiation is 0. Denominator, cos x differentiation minus sin x. Then apply the limit. First one, keep the 2 as it is. Since the cos pi by 2 is 0, we will get the multiplication of pi by 2 will get the 0. Second term, the sin pi by 2 is 1. Denominator minus sin pi by 2 equal to 1. So we will get the answer minus 2. Next problem, limit of x log x as x tends to 0. So if you apply the limit for this problem, the first limit 0, the log 0 is infinity. Since the 0 into infinity is sub-indeterminate form, convert into standard indeterminate 0 by 0 or infinity by infinity by considering any of the term to the denominator. That is, you have the x and log x, both the term you have. So rewrite this term, the limit of, you can't write the log x denominator, keep the log x as it is. Write the x as 1 divided by x. Now we apply the limit, the log 0 is infinity, here the 1 by 0 is infinity. Now we can apply the L'Hospital rule. By L'Hospital rule, the limit of x tends to 0, the log x differentiation 1 by x, 1 by x differentiation minus 1 by x square, then cancel these two x, simplify this, since you have the negative sign, take this to numerator, you will get the minus x as x tends to 0. If you apply the limit, you will get the answer as 0. The next problem, limit of a minus x tan pi x divided by 2a as the limit x tends to a. If you apply the limit, the problem tends to the first one, a minus a will get the 0. Here a and a get cancelled, the tan pi by 2 will get the infinity. So the problem tends to 0 into infinity form. So you convert into standard indeterminate, write any of the term to the denominator. In this problem, I write the tan x to the denominator. So the limit x tends to a, keep the a minus x as it is, write the tan x to the denominator, you will get the cot pi x divided by 2a. If you apply the limit, the numerator a minus x, a minus a will get the 0, denominator cot pi by 2 is 0. So the problem is, rewrite the problem, you will get the term 0 by 0, that is the problem tends to 0 by 0 form. You can apply the L'Hospital rule. By L rule, limit of x tends to a, since a is constant, the differentiation is 0, x differentiation is 1, denominator cot x differentiation minus cosecant square x pi x divided by 2a, differentiate pi x by 2a, you will get the pi divided by 2a. Then cancel the negative and negative sign, simplify this, take this term to numerator, we will get the 2 divided by pi, apply the limit, limit as x tends to 0, x tends to a, 1 by cosecant square, a and a get cancelled, cosecant square pi by 2. Since the sin pi by 2 is equal to 1, the cosecant pi by 2 is also equal to 1. You will get the answer as 2a divided by pi. So the next forms of indeterminate, it is 0 by 0, infinity power 0 and 1 power infinity. Then how to solve this problem? Consider the example. I'll take the first one. Limit x power x as x tends to 0. If you apply the limit for this, so 0 power 0, you will get the 0 power 0 form. Then first you consider the given term as y, then apply the log, then you can solve the term. So to solve this problem, I can consider, first I take this, write the solution, let y equals x power x. Then apply the log on both sides. Log y equals log x power x. So you have the property log a power m. You can write this term as x log x. Since log a power m can be written as m log a. This is the log y. Then in the problem, given the limit x tends to 0. So apply the limit as x tends to 0 on both the sides. So limit as x tends to 0, log y equals limit x tends to 0, x log x. Soon after this, apply the limit for the RHS part. So if you apply the limit, for the x is 0, the log 0 is infinity, the limit tends to 0 into infinity form. Then convert into standard indeterminate using the previous problem. You can write this term as similar as the previous problem. You can write this term the log x divided by 1 by x. So the function takes the form, the log 0 is infinity, denominator 1 by 0 is infinity. So it is infinity divided by infinity. And in the LHS you have the limit with log y as x tends to 0. RHS part, you have the limit log x divided by 1 by x as x tends to 0. Then since it tends to indeterminate form infinity by infinity, you can apply the L'Hospital rule by L'Hospital's rule to the RHS part. Limit of x tends to 0, the log x differentiation 1 by x, 1 by x differentiation minus 1 by x square. Cancel this, then apply the limit, you will get the answer as 0. In the LHS part, you have the limit of log y as x tends to 0. Since you have the property, the limit of log can be written as the log of the limit. You can interchange these two. You can write the log with limit of y as x tends to 0 equals, you got the answer as 0. Then the limit of the log with, you have the log with base e, limit y as x tends to 0 equals, take this log to the RHS part, you will get the e power 0, the e power 0 equal to 1. That answer is 1. This implies that you taken the y as x power x, limit of x power x as x tends to 0 equals 1. this the answer.